Hello and welcome to another Arch Linux video. By a recent request from some of you, today we're going to install Arch Linux onto a ZFS root file system. Pretty exciting, so let's get started. ZFS on Linux is currently CDDL licensed, which is not compatible with the GPL, so Arch won't include it on their stock ArchISOs, which is understandable. So before we can perform a ZFS Arch install, we need to first build our own custom ArchISO where ZFS is already integrated and enabled. Let's do this now. Here is the Arch Wiki Linux ZFS article that I relied very heavily on. As you can see, it is very in-depth and not trivial, but I found a golden path to get this to work. As they warn you here, blindly copying and pasting this wiki will not work. So you need to know a little bit of what you're doing. Why you have to go through all this? Software Freedom Conservancy has a good article here about the GPL violations related to combining ZFS and Linux. And they discuss the basic facts of the case and a summary of their conclusions. So it's incompatible with GPL, so Arch Linux will not include it, ZFS. So if you want to get quickly going with a custom ArchISO, I recommend Esnix project, Easy Archer project. Esnix creates some fantastic ISOs to help you get a ArchISO build machine up and running quickly. I'll leave a link in the description below. Highly recommended. Guy does amazing work there. So let's get cracking here. So this is what we're running. We need an Arch Linux system in order to build an ArchISO. So let's make sure our build system is up to date with sudo pacman-syy. I'll enter my password. Looks like we're up to date. Let's sudo pacman-s ArchISO. It's already installed, but let's reinstall for good measure. We'll need this to do the rest of this task. So let's make dir ISO build directory. And let's copy recursively user share ArchISO configs relang for release engineering ISO build, and that puts relang, which we'll rename to ZFS ISO. That puts the build files for building the ISO into our build directory. So before we continue with that, we need to grab a couple of GitHub projects here, Git projects, with git clone, aur.archlinux.org, zfs-dqms.git. Those are the ZFS kernel modules. Let's cd into that directory. And let's make package --skip pgp check. We'll keep the signature checking simple here today for this demo. We're in a hurry, so okay. So that's built, and let's take a look. There it is. There's our package that we just built for our ZFS kernel modules. Let's go back to the home directory and get the second of two packages with git clone https://aur.archlinux.org/zfs-utils.git. So let's get projects. Very handy for building the packages that we need for a custom ArchISO. So let's build the utils package with make package --skip pgp check, as we did before. And this will take quite a while, so I will skip over this with the magic of video editing so you guys don't get too bored. And there it is. Okay, package 2 of 2 packages. kernel modules and the utilities. All right, let's go into our ISO build, ZFS ISO directory. This is what it looks like. And let's create our custom repo directory here with mkdir ZFS repo. Let's cd into it. And let's copy our packages that we just built from zfs-dkms, star.zst, and also copy into this directory our utilities package, star.zst. Good. So we have two of our packages here that we just built in our repo directory. Let's create the database with repo-add zfsrepo.db.tar.gz star.zst. So we'll add these two files to the repo database. Description and files entries are created. That's how quick it goes. All right, so let's edit the packages file here because we want to include our custom packages. And at the bottom here, let's include the ZFS custom repo comment section. And let's add Linux-headers. We need that for DKMS. It's not included by default. And also our freshly built ZFS-DKMS package and our ZFS-utils package. And we should be set for our packages file. Next, let's edit pacman.conf and add our custom repository at the bottom of this file. We'll call it ZFS repo in square brackets. We'll do the signature level or sig level equals optional, trust all, and server, or local files, file : 3/, home, Stephen, ISO build, ZFS ISO, and then ZFS repo, our custom repository. That's it. So I think we're just about done. We just need to create the working directory with work and the ISO output directory or ISO out. So let's become root with su. And let's do the deed with make ArchISO -v -w work and -o ISO out dot for the current configuration. And there it goes. It downloads all the packages, integrates them, and builds the ISO, our custom ISO. And there's our custom ISO. Now we can boot from our custom ZFS ArchISO and actually perform an install. We'll keep this demo install as simple as possible and skip encryption and other complexities. Here's our ZFS-aware custom ArchISO. Let's set font Terminus 128N so you guys can see this text a little better. We've got our networking configured. We've got dev VDA as our target disk, so let's gdisk and partition it. Let's create our EFI boot partition at 600 megabytes so that we've got a init RAM FS fallback space. Make it EF00, and also our Solaris root partition for the rest of the disk, which will be our ZFS root partition. There we go. Let's write the partition table. All right. So let's makefs.vfat/dev/vda1. That's our EFI boot partition as FAT32. Let's modprobe ZFS to load the Zfs modules and check that they are loaded. It looks like they are. Very good. We will proceed with creating our zpool. Zpool create -f-o A shift equals 12, and we'll do a new line, -O ACL type equals POSIX ACL, new line, -O rel time equals on, new line, -O XATTR, attribute equals SA, new line. All these are from the Arch Wiki, by the way. If you want to read about these, you can take a look there. Dnode size equals legacy, new line, -O normalization, a whole bunch of options here, equals form D, new line. Another option would be mount point equals none, new line, -O can mount equals off, new line, -O devices equals off, another new line, -R/mount, new line, and then finally zroot, which is our zpool name, /dev/vda2, which is the second partition of 2. So there's our pool, zpool, created on the second partition. Zpool status shows no known data errors, so everything looks good. So let's do a whole bunch of ZFS create commands here with ZFS create -O mount point equals none, zroot /data, and then do another ZFS create -O mount point equals none, zroot /root on all caps, then ZFS create -O mount point equals /-O can mount equals no auto, zroot /root/default. Then ZFS create -O mount point equals /home, zroot /data/home. And next group is ZFS create -O mount point equals /var -O can mount equals off, zroot /var, and then ZFS create zroot /var /log, and then ZFS create -O mount point equals /var /lib -O can mount equals off, zroot /var /lib, and then ZFS create zroot /var /lib /libvirt for your KVM virtual machines. That's where they can live. Also, ZFS create zroot /var /lib /docker for your Docker containers if you want to store them there. Good. A whole bunch of ZFS creates. No pain, no gain, right? Then zpool export zroot. Export the pool, then import it with zpool import -d /dev/vda2 /r /mount zroot /n, and hit enter. Export import, standard procedure. ZFS mount zroot /root /default, And then we mount the rest with ZFS mount-A. ZFS handles all the other mount points. We can check by doing a df-k. So you can see we've got all the zroot mount points under the ZFS root. Looks all good. So, zpool set bootfs equals zroot / default, and then zroot as the pool. Then zpool set cache file equal /etc /zfs /zpool.cache. The zroot pool is what we're using. Then mkdir, a couple of directories here. Under /mount, we have etc zfs, and also boot EFI for a boot partition mount point. And we'll copy the cache with copy etc zfs zpool.cache. We'll copy that into /mount /etc /zfs /zpool.cache. And there we go. Next, let's mount /dev /vda1 on /mount /boot /EFI. That's our EFI boot partition for our Intel machine. And let's pacman-syy. And let's packstrap into /mount base dkms git intel-microcode amd-microcode if you have an AMD box. We also want Linux firmware, Linux headers, Nano, and Vim for a pair of editors come in handy. So that downloads and installs these packstrap packages. Into our ZFS root system. Okay, that's done. Looks good. Looks like it was successful. So let's generate the file system with file system table with genfs tab -u -p /mount, and let's write that out to /mount /hc/fs tab for file system table. Let's arch-chroot into /mount, and we're change rooted. Let's edit the file system table, and let's comment out all the zroot entries, because ZFS handles these auto mounts by itself. Doesn't rely on the file system table for that. So make sure all these zroot entries are commented out before continuing. And next, vim etc pacman.conf. At the end of this file, we need to add a custom third-party repository. Call it ArchZFS, that's what it is. Let's do the sig level equals optional trust all. This is a breaking point for Arch Linux and ZFS because it relies on a third-party repo, namely this one. And if it's not up to date with the latest Linux kernel that Arch Linux has in its mainline, your system might break. So word to the wise, be caution here, have caution here. It's my recommendation. So anyway, that's the entry for our third-party ZFS repo. So let's make sure our databases are up to date. Looks like we have to import a PGP key from ArchZFS repo. That's done. Because we need to install from that repo pacman-s zfs-linux. We need that package installed in our Arch Linux ZFS root system. So that's done. That happens. But fortunately for us, that repo was up to date. So let's vim etc mkinit.conf here. And let's change the hooks around a little bit. So the Arch Wiki recommends that we load the hooks in the following order. We want keyboard after block. We want ZFS after keyboard. So we can get rid of the rest here. So that's it. That's our hooks line for makeinit copyio.conf. And let's make init copyio. We're running Linux here. Linux kernel. So that was successful. Next, let's pacman-s. Let's do a whole bunch of packages. base-devel, EFI boot mgr, grub, network manager, network-manager-applet, OpenSSH, OS-prober. We'll do a new line here. So it doesn't get too long. Next line, we do reflector, rsync, terminus font, which we're using right now, WPA_supplicant, XDG, -user, -dirs, XDG, -utils, zshell, and grml-zshell-config, which is a great starter configuration for your zshell. I like zshell very much, so I'm going to install it today. So this pulls in a whole bunch of packages and dependencies, so we'll let it do its thing. A solid base system you can build on later. Okay, that's done successfully, it seems. Let's vim etc default grub. We've got to do some ZFS specific stuff here, but first on my virtual machine I need to enter video equals 1920 by 1080. You probably won't need to do that if you're not on a KVM. And then for ZFS, we need to put in the command line Linux section here, root equals ZFS equals zroot /root/default. That'll make it be able to boot from the ZFS root partition. All right, so that's done. So let's do grub-install --target equals x86 _64-EFI, and then --EFI directory equals /boot/EFI /bootloader /ID equals Arch Linux, exactly the way I always do with my Arch Linux installs. No change here. Standard command, no error reported. That's always good news. Let's then do grub-mkconfig -o /boot /grub/grub.cfg. Make sure that's in there. Yeah, including the fallback init RD images. We got both images ready to go. Yay for 600 megabytes of EFI partition. Systemctl, enable network manager. We'll also want to enable the reflector.timer service. Also SSHD. Let's also enable ZFS-import-cache. Then also enable import-scan, or ZFS import scan, ZFS-mount service as well, and the ZFS-share and the ZFS-z. And check the Arch Wiki what all these do. ZFS.target is our final and systemctl enable line. And we'll do ln-sf, and I'm in the Los Angeles time zone, or the US Pacific time zone. We'll link that to etc local time, as per usual in Arch Linux setups. Let's sync the hardware clock, sys to HC. Then let's stream edit, or sed, -i, single quote, s/pound-en_us.utf-8. And we want to uncomment it with /en_us.utf-8. That uncomments this line from the /etc/locale.gen. And then we want to run locale-gen. Should do the trick in one line of code. So there it is. Uncomment and then run the locale.gen. So let's echo, in quotes, lang equals en_us.utf-8. And we'll write that to /etc/locale.conf. Then we'll do echo. We'll call this host, this machine, Ziffy. We'll write that to /etc/hostname. And next we'll echo 127.0.0.1 as localhost. We'll put that in the /etc/hosts file. Next, we'll also do, that was IP version 4. Let's do IP version 6 with ::1. Let's line up the localhost. Good. So that's the second line. Third line will be 127.0.1.1 ziffy.localdomain. We'll type Ziffy one more time. We'll also write that to /etc/hosts. Let's take a look at what the host file looks like. Make sure it looks okay. Looks perfect. Great. All right, moving right along. Let's do add my user account with user add -mu -s. I want my Z shell. I'll add myself to the following groups. A new line: sys, log, network, floppy, scanner, power, rfkill, users, video, storage, optical, line printer or LP, audio, wheel for sudo, and ADM for administrators. And the new line, and my account name will be Steven, of course, because that's who I am. All right, let me give myself a password with password Steven. Let me enter it once, enter it twice. Let me give root a password with just password. Enter that one once and twice. And there we go. Steven and root have passwords now. Let's via sudo. Let me add myself wheel users to the sudoers with %wheel as all. So I'm of group wheel, so I can become sudo or use sudo, become root that way. All right. Let's cd into etc xdg reflector. Let's back at the reflector.conf up. And let me copy back over to reflector.conf. Got it backed. It backed up the standard file in case we screw this one up. You never know with what can happen. You know what? Let me just clear this entire file here. Let me just write it out from scratch. My first line for reflector.conf will be my country, which is US. So dash country US dash protocol. I want to use HTTPS, secure HTTP, dash latest 5, dash sort by rate, and then dash save it to the /etc/pacman.d/mirrorlist file. Look, that looks good. So our reflector is set up to only use local fastest repositories for my area of the world. Okay, we're done. Exit, unmount the /mount EFI directory. And then we want to ZFS umount -a. And then we want to zpool export zroot. And then we are ready to reboot. So crossing fingers here, folks. Hopefully this is our ZFS Arch Linux install. Yep, looks like it is. Let me log in. As Steven, there's my password. Okay, let's make the font something reasonable with Terminus -128N. There we go. Looking good. Let's make sure we're up to date with sudo pacman-syu. And looks like all our repositories are up to date. As you can see, we are indeed running Arch Linux on a ZFS root partition. Those are all our zroot mount points. So it's working great. So let's test ZFS a little bit here. Let's do zpool set list snapshots equals on zroot, so we can do some snapshotting. It's a good way of testing, right? So ZFS list -t of type snapshot shows no data sets available, which means we haven't done any snapshots yet. So let's create our first snapshot as installed. So ZFS snapshot zroot/root/default at base_install. That's our base installation. So let's list our snapshots now, and look at that. We have our first base install snapshot. So let's see, what can we do here to test ZFS snapshots and rollbacks, right? So let's see if NeoFetch is not installed. That's right, I did not install it originally. So let's install it now with pacman-s NeoFetch. And that's done. Pretty quick system. NeoFetch, there we go. Root at Zfs. Fairly recent kernel. ZFS caches to RAM, so we got 421 megabytes available, used out of 8 gigs available. So let's roll back. Say I didn't want to have this package installed or some configuration, right? So ZFS rollback zroot/root/default at base install, and happens instantaneously. We've rolled back. So NeoFetch is, of course, no longer found. Of course, you can always obviously do pacman-r NeoFetch if you wanted to uninstall the package, but yeah, that's not part of this test. So it appears that ZFS is running properly. And so there you go. Looks like we were successful and can now install a desktop and your favorite software as you normally would. Because ZFS can't be integrated into the Linux kernel due to licensing issues, in my opinion, it's not a robust solution since it must depend on third-party repos. So for now at least, if you need copy on write and snapshotting, I will keep recommending Btrfs instead of ZFS root file systems. Leave ZFS to Solaris and the BSDs, where it will be much happier. I hope you found this video useful. For more of these, send some love and like and subscribe, and do leave comments below. Until next time, take care.